Hello everyone, my name is Dr. Kunal Patel, and in continuation with our linear regression model example, today we are going to solve our previous student grade history example with the use of machine learning, right? So in last session we have seen that we have solved that example with the statistical formulas, mathematical formulas, and we are getting this kind of responses, right? That is pretty much closer to that. Now in this video we are going to solve that same example with the use of machine learning. So to solve this example with the use of machine learning, first of all, as usual, these are the three important libraries we need to import. Then we are going to use matplotlib inline, but here we are not going to draw that line today. Okay, so you can you can simply draw that line as I have used in my previous example. But our main focus today is how you can train our model with the use of machine learning. So here for that we need to import linear regression class from the scikit-learn library. So here we are using scikit-learn library. That is a very important library for the particular statistical models and all that. So these particular classes, another class we are going to use, that is a linear model, another is a matrices class, and for that we are going to use another mean squared error. So all these classes will be used to perform linear and polynomial regressions and make the predictions accordingly. So these are the important classes you have to import first of all. Then next step is very simple. You need to read the data, right? So with the use of read CSV function, we are using the same grade history student data and we are going to display it, right? Now our main task starts. First of all, to feed the model, to create the model, you require all the data either in a 2D array, right, or a similar kind of object, right? So the first of all we are going to generate this particular data in array. So here capital X and capital Y, data dot values. So these are our regressors, these are our inputs, and Y is equals to data Y values output. These are our predictors and that is a Y. Now here, to convert this particular data in a two dimension, there are two ways. These are very simple ways, right? So first of all, you can find the total length of values, means in X how many values are there with the use of length function, and we are going to store it in n. Now how we can use this n value to reshape? So to reshape our data in a two dimension with the use of reshape function, first of all you need to call the reshape function on our variable X. There are two ways, as I told you. One is this, you can pass -1 tuple, or you can pass n comma 1. So n, this is our total number of rows and one column. We want one column only, right? And total number of rows according to our X value. Now after reshaping that, we need to first of all create our model and fit it, right? So to create a model, I am taking a model variable and linear regression mojo, right? So here we are creating the object. Okay, so this is our object. Now to feed the data, we are going to use a feed function. So the feed function is used to calculate the optimal values of weights b0 and b1. So in yesterday we have calculated this value with the use of these b0 and b1 functions, mathematical formulas. So we don't need to write these formulas, we don't need to implement this logic. Directly it is available with the use of feed function. This is the beauty of feed function, right? So it uses your existing input and output as an argument. So x and y are our inputs and outputs, and with the use of feed function now we have fitted our data. The next step is now we need to predict the value. Okay, so to predict the value I have created another variable y predict, and here again I'm going to use a model dot predict x. Okay, now here you can see that we are going to predict the y values based on the x inputs. So for all the x values we are going to calculate the y predict. So we are going to achieve this with the use of this formula y is equals to b0 b1 x. Okay, so here instead of that we are going to use prediction value b0 and b1 we have calculated with the use of fit function. You just predict the values, and to calculate the best fit, that is our r square, it is also known as the coefficient of determination, and for that the formula we have in my previous video used this formula, but as usual we don't need to write this logic. All this logic will be performed with the use of one function only, that is core function, right? Again you need to pass the x and y value, and we are going to calculate the r square, right? So now if you execute this code, then you will get all the predicted values with respect to x values or y predicted value, coefficient of determination, that is our r square, that is 0.48. Yesterday we got the same result, 0.48. Intercept, that is our b0, and slope, that is our b1. So 26.78 and 0.64. So here 0.64 and 6.78. So you will see all the results we are getting the same, right? So this is the beauty of the machine learning, right? All the statistical value, this is the difference between this, right? Why machine learning is powerful. So instead of going the particular uh, traditional or mathematical formulas, we are going for the machine learning algorithms, and with the use of that inbuilt functions we can create the same results and accurate results, right? So I hope this video is very useful to you. These are the very simple video I have made guys for you. If you understand this video thoroughly, then you will crack any linear regression problem with the use of machine learning. Okay, thank you, stay tuned.